Okay. Okay, Isabel, if it has eating, it's fine. Okay. So this week's lecture is a little bit different. We will do this some of the questions together. We'll see how many questions we can finish. For each question, I will give you a few minutes to read it, to think about it, and ask you if you have any idea or any thought on this and how to solve them. Okay, let's start with the first part. The first part is about parallel lines and transversals. First, let's recall what is the corresponding angle. Let me try to draw two parallel lines and a transversal. Labeled angles 1, 2, 3, 4. Okay, we have some angles here. Give me an example of corresponding angles. I'll start with Jessica. Jessica?
Um, so corresponding angles, they're they're like
Examples?
7 and 2.
7 and 2. That's the
I mean
first
three,
one. I'm
three,
sorry?
seven
7
and
and 3. Okay.
yeah.
Yes. Okay. So angle 7 and angle 3. Okay. That's correct. Next one, alternate interior angles. Eric, give me an example of alternate interior angles.
Um, 2 and 4. Wait, 2 and 8.
2 and 8. Okay. So angle 2 and angle 8. Okay, you mentioned the 2 and 4. What are they? 2 and
Oh,
4.
vertical angles.
Yes. 2 and 4 are the vertical angles. This vertical is related to vertex. These two angles share the same vertex. Okay. Next, co-interior angle. This is something we didn't introduce. The co-interior angles. Interior angles on the same side. Okay. First one is easy. We move to the second one. Let's read the question. Two lines are parallel. Cut by a transversal. Transversal. Let's label this A, B, C, D, B, F. Let's move F up. If one of the alternate interior angles matters, let's see this one, 65. So if we pick this measure, the alternate interior angle will be this one. Ah, I should pick a different one. This angle is the alternate interior angle. By the previous theorem, they are the same. This one is also 65 degrees. Now we're asking the corresponding angle. Corresponding angle by the previous theorem is the same. Okay, so this one follows direct from the definition. Okay, the third one. Again, I'm going to draw a picture. One of the co-interior angle is okay. So for this angle, the co-interior angle will be this one. Okay. Now, what's the measure of the other co-interior angle? Aaron,
72,
how do you get that?
because they're on the same side. So something plus 108 has to equal 180s.
Okay, so the summation of the two co-interior angle is 180. Okay. The last one, the first part, we have two lines. We can parallel. Angle 1 and angle 2 alternate interior angles. Let's pick this one, angle 1, angle 2. These two angles tested by these equations. Okay. How do we find x? Amy, what do you think?
So that means angle 1 on the other side. So you would like subtract 15.
Okay, step by step. So first, the two angles are the same, right?
Yeah.
Okay, so we have an equation.
So yeah. So 3x plus 15 equals 5x minus 5.
Okay, how do we solve this?
And then you can that would be 2x equals 20. So x equals 10.
Okay, it's a combination of geometry and algebra. From the geometry, we know the two angles are the same. Then we have an equation. We can solve x from the equation. Nice. So first part, move to second part. Second part about congruent triangles. Okay, Kira, let's recall the definition of congruent triangles. When are two triangles congruent?
One have the same shape and size.
Okay, same shape and size. Okay. So to determine if two triangles are congruent, we have four theorems. Okay. Jessica, what are they? The four theorems.
Like side, I guess.
Yes, okay.
Side, angle, side, angle, side, angle, angle, side.
Okay, the four different theorems. First one's easy. We have two triangles, ABC with three sides, DEF, three sides. Are they congruent? And what are the corresponding vertices, corresponding sides. Kira?
DE corresponds with ACEF with BC and DF with AB.
Okay, so let's step. So DE corresponding to Kira
AC.
again. AC. EF.
EF. Oh, BC.
BC. And DF.
AB.
AB. Now the vertices. D.
Um.
E, F. Okay, so we found the sides and we want to match the vertices. DE, DF. If we look at the first and the third one, you have a common vertex
So
D.
D is with A.
D is A. Okay. And
E is
E.
C.
E, how do you get that?
Because like the D and the EF are both matched.
First one, second one, they both have
Yeah.
E, they both have C.
Mhm.
And F,
With B.
only B left. Okay. So we have the correspondence. Now we can check DE, DE for AC, EF, EF for BC, DF for AC. Okay, so we match the sides and the vertices. Second one, we have an isosceles triangle with the two sides, AB and AC are the same. We pick a point as the midpoint of the base. We want to prove that the two triangles are congruent. Let me draw a picture and ask you how to prove this. Okay, it's about right. I label this A, B, and C. I pick the midpoint. D. And I connect. Okay, whose turn? Eric. An idea why these two triangles are congruent? What theorem do you apply?
Side angle side.
If we say side angle side, which is two sides? Which angle?
Side BD, CD, AD, and AG, and angle ADB and ADC.
Angle ADB, ADC. Why are they the same?
Because since D is the midpoint of BC, that means BC and DC are equal.
Uh-huh.
And then AD is just equal to itself.
Uh-huh.
And then wait. Yeah.
Okay, still missing. What about the angles?
Oh, wait.
Okay.
Technically, since it's the middle, AD counts as the altitude of the triangle.
Okay, so that needs some property. This is the altitude. If because the two triangles are congruent. These angles are the same. So each is 90 degrees. They are perpendicular. This follows from the conclusion.
Okay, fine. Side, side, side.
Okay.
Side. Since it's an isosceles triangle, AB equals to AC.
Okay. So let's change our theorem. We switch to side, side, side. Because it's an isosceles triangle, we also have AB equals AC. Now we see that two triangles are congruent. Okay. Next one, I'm going to draw a triangle. Make it looks nice. I will draw the altitude. See the difference. Previously, I draw the median. This time, we draw the altitude. A, B, C. The extra information about this altitude is that it's also a bisector, the angle bisector. Now we want to prove that this triangle is an isosceles. So it's the other way. Amy, an idea to prove this? Why it must be isosceles?
Well, you would have to prove that AB equals AC, and they are equal because we already proved that they're congruent.
You mean from the previous theorem?
Yeah.
In the previous one, we have the condition that ABC is isosceles, but this is what we want to prove. We don't know yet.
So it's bisecting. That means BD equals DC, and
Normally, when we say bisector, this means the angle bisector. Maybe I should make it more explicit. Angle bisector. The bisect angle BAC. Okay, make the condition more explicit. So,
so you could use like ASA, maybe.
Okay, nice.
Yeah.
So ASA, what's the side?
The side is AD, and then the angles are BDA, CDA, BAD, and CAD.
Okay. These two angles, why are they the same?
Because if it's an angle bisector, well, it's like bisecting BAC.
Okay.
And then so
okay, it's
yeah.
this one. Okay.
Yeah.
What about this one?
Because both of them are perpendicular.
Okay, so because both are 90 degrees. One is 90, the other is also 90. Okay. So we can apply the ASA theorem. And okay, next one, we start with a triangle. We don't know it's an isosceles triangle yet, but we will prove it. The condition we have this time is that the altitude is a median. Let's draw the altitude. Compared with the previous one, the altitude is the angle bisector. This one, the altitude is median. How to prove the triangle is isosceles? So similar conclusions, but different assumptions. Kira, any thought on this one? The altitude
What's
is also
what's a median again?
median. That means this point is midpoint of BC. Mm-hmm.
I need to think for a second.
Okay, midpoint.
Could you like prove that the AABD and ADC are congruent? No, that's not gonna work. I mean, yeah, that actually could work. Like the two triangles on either side of the median are congruent.
Okay. So your step is the two triangles ABD, ACD are congruent. What's the argument for this? Why are they congruent? What theorem you apply?
SSS. Well, no,
SS.
you can't do that. SAS.
SAS. Which angle?
The right angle.
Okay, so angle ADB, angle ADC, because both are 90 degrees.
Mhm.
Which
And
two
then AD
sides?
equals AD.
Mm-hmm.
And then BD equals CD because it's a midpoint.
Okay. Because the midpoint, we can apply the SAS theorem. We conclude the two triangles are congruent. Therefore, the two angles are the same, the two sides same length. Okay, question about these two parts. Easy, we'll get more interesting ones coming. Next one. Triangle XYZ have a segment connect the midpoint of the two sides. Simple one. We have X, Y, Z, the midpoint of the side, X, Y, X, Z. Midpoint, midpoint, we connect. M. What do we know is YZ is 14 centimeters. Samuel, what's the length of MN?
All right. See.
This is 14. Does it help to find MN?
Wait. Wait, which theorem are you supposed to use for this? Like,
Can I
Yes,
check
that's
my
part.
notes?
That's part of the question. What theorem could we use?
I think you're supposed to use a midpoint theorem, whatever it's called.
Okay, okay. Eric is agreeing with you.
Alright.
Midpoint.
Wait, then it should be divide 14 by 2, right?
Yes.
If it's
So
midpoint, so it's 7.
MA is YZ divided by 2.
So it's 7?
Mm-hmm.
Alright.
The units centimeters. Okay. Next one. Next one, a triangle angle C, 90 degrees. Median to the, let's pick the midpoint. We call it M. Connect the CM. Okay. So CM is our median. Now we want to prove that this is half of the hypotenuse AB. M is half of AB. Okay, let's think about it for a few minutes. How to prove this? Let me check. Okay, we are here. Aaron, any thought on this one?
I forgot which theorem to use. I kind of forgot.
Okay, okay, okay,
Let me just check.
okay. Eric, what do you think?
Wasn't it like the hypotenuse median theorem or something?
Okay, so now let's give a different proof of this conclusion. What I do, okay, to save some space, I'm going to put M there. I'm going to make a copy of the right triangle.
Mm-hmm.
Okay, so I make a copy of this. Now let's, what can we say about this quadrilateral ACDBD?
They're congruent. It's a rectangle.
A rectangle. Okay, it's a rectangle.
And also AB is a diagonal.
AB, okay, step by step. So a different proof. Draw the rectangle. ACBD. We know that AB is a diagonal. Well, that's the setup. Now why CM is half of AB? Eric, waiting for you. Why? It's useful information. How do we use this? Okay, so one property about rectangles. Let me rewrite my rectangle. What do we know about the diagonals of the rectangle?
They're equal.
One, the equal length, and they meet at the midpoint, right?
Yeah.
So AB and CD. So now we have CM is half of CD, and CD is the same as AB.
Mm-hmm.
Okay, so we give a different proof of the fact that this hypotenuse median is half of the hypotenuse, because we can compute this to a rectangle, and the two diagonals of a rectangle intersect at the midpoint, and they have the same length. Aaron, do you agree with this proof? Any question about this one?
Could you just write a dot to see where M intersects?
Okay, let me put a dot over there. Okay. Okay, next one. Again about right triangle. Draw the median. Let's start with a right triangle. A, B, C, M. Find the midpoint. And the opportunity, let's draw the altitude. Well, it's not easy. Let me try to draw, make it as accurate as possible. Let me check my body. Oh, it's fine. It's not bad. So this will be H. Mark the points. 1, 2. Okay. The problem was this angle, HCM, this angle, is a difference of the acute angles of the triangle. The difference there should be B minus A. And go HCM. Okay, let's see why. Whose turn? Okay, the order changed. Maybe I'll go with Amy. Any thought? Okay, if no, let's do it. It's okay.
Because like the angle BCA is equal to 90. So
BCA, yes, 90.
yeah. So BCH HCM and MCA have to add up to 90.
Yes.
So, and then if you change that equation,
Okay, give me 1 second. Let me write down. So step by step. So angle BCH, angle HCM, angle MCA 90. Okay, first step. Second step.
so HCM equals 90 minus MCA minus BCH.
Okay. HCM 90 minus. Which one you go on first? BCH or MCA? That doesn't matter.
I don't really care.
Okay, MCA BCH. Okay.
And then so yeah, I'm kind of stuck.
Okay, yeah, that's okay. That's okay. Let's think about it. MCA, BCH, BCH. Okay, so BCH. Are these two angles comparable, Amy? This angle and this angle A. BCH vs angle A.
Yeah, they're
Why?
equal.
Okay, there you go. Why?
Because the hold on, I'm blanking out. I had it just now.
Uh-huh. Yeah, it's not easy to answer immediately. That's normal.
So angle MCA equals angle MAC, I think.
Okay, that's the key. MCA, MAC. MAC. Why are they the same?
I think a triangle CMA is an isosceles.
Okay, because so what we have just proved, this one is half of the hypotenuse. This
Yeah.
is the midpoint. So these two sides are the same isosceles angles. So MCA is the same as angle A. So it's 90 minus angle A minus angle A. Now 90 minus angle A. Amy, what's this angle?
90 minus angle A equals angle BCM.
So this one is easier. We have this right triangle. The summation of these two angles is
90.
okay. So you take the difference, we get
45.
angle B.
Oh, okay.
Okay, so that's what they are looking for. It's angle B minus angle A. Okay. Okay, we'll take a little bit of steps, but we used what we have just proved that the median, the hypotenuse, is congruent to half of the hypotenuse. Therefore, this triangle is isosceles. So that's the key for this problem. Next one, line segment connecting any point on one basis of a trapezoid with any point on the other base is bisected by the midsegment of the trapezoid. Okay, let me draw a trapezoid. make it general. Okay, not bad. A, B, C, D. Any point on one base, I'm going to pick this one. Any point on the other base, make it non-symmetric, I pick this point. So I connect the line segment. The conclusion is the mid-segment. Mid-segment of the trapezoid will be two midpoints. Let's call them M and N. Okay. We want to see that this segment is bisected by the mid-segment. Let's think about why. Okay, I will mark the intersection. I call this point G. Why? This is the mid-segment. Whose turn I thought? That was Amy. Maybe Jessica? Okay. So think about it. How to verify this? That the G is actually the midpoint of EF. So any point here, any point here, and Kira, any thoughts? It's not easy to prove that directly. We need some help. Okay, let's have 5 minutes break. We will resume at 8:18. And Kira, think about this. I will ask you again. Okay, resume at 8:18.
Okay.
Okay. Okay, Kira, any thought on this one?
Not really.
Okay, okay, let's try to reduce it to what we have learned. We learned a lot about triangles. We will create a triangle. There are different ways. Okay, Kira, give me 1 point. A, B, C, D, 4 points. Pick, which one you want to pick?
C.
Let you pick C. You pick C. Let's see how to use C. Okay, I'm going to. You pick the hardest one, but let me use a different color. C. We try to move this point a little bit forward on E. Okay. So by the midpoint theorem, the trapezoid, we know that MN is a parallel to CD. Okay. MA is parallel to CD. How do we use this information? Okay, I'm going to mark this point, H. Aaron, any thought?
We could say MN is parallel to AB as well.
Okay, that's also true. We want to see that this G is actually the midpoint. Why this G must be the midpoint of EF?
Oh yeah, C intersects FE at E, I think.
Put that again. C.
E intersects FE at E, I believe.
So we connect CE
Yeah, and FE.
and FE. Okay, what's next?
I forgot. I had it in my head and I forgot.
Okay. Isabella, unmute us. Amy, what do you think? G, the midpoint.
I actually do not know.
Okay, so I will give you a hint. Let's consider this triangle, ECF. Does it help? Triangle CAE. Okay, let's look at this triangle CAE. CAE. We
That's
know
90
that.
degrees.
No.
Wait, no,
So
no,
this
sorry.
is
I was looking at 3D, so I thought it was 90 degrees, but it's not. Never
okay.
mind.
Not really, just our plane. Okay, this triangle. What do we know about this point, M?
M intersects CA at CA, I believe.
M is the midpoint of AC.
Mm-hmm.
Okay, so M is the midpoint. Let me rewrite. So we start with the triangle.
Okay, and then
C.
if M is midpoint of AC, then I can say N is midpoint of BD.
Yes. So this is the condition by the mid segment. So MN is the mid segment. The mid segment is MN. Let me move this a little bit. Then this mid segment is just MN. The trapezoid, so this will be E N point F. What we know M is the midpoint of AC. We also know MA is parallel to AB. In particular, MH parallel to AE. What can we say about the point H on CE?
It can also
Okay,
be the point.
what's that, Aaron?
I'm not quite sure, but H midpoint of CE.
Eric? Okay, Eric agrees. Why? What theorem?
I forget what it's called. I know this theorem, but I forgot what it's called.
Okay, Eric, help.
Uh, I forgot.
Okay, who can help us? Oh, CE.
Is it? No, it's not the midpoint theorem. No.
Well, it is.
Hmm?
It
Wait, what?
is. The
Wait,
midpoint
what?
theorem.
Oh, wait.
Wait, but
Yeah, triangle
that
CAE. AE is parallel to MH, and M is the midpoint of AC. So H
Oh
is
yeah, wait,
midpoint of
yeah.
CE.
I overlooked that part. Whoops.
Okay. That's our progress. Now we know that H is the midpoint of CE. Now we look at the second triangle, ECF. What do we know? Okay, Eric.
It's the same thing. Triangle CEF or ECF.
Uh-huh.
H is midpoint of CE and HG is parallel to CF. So G is the midpoint of FE.
Okay. So
I
we
support that.
okay. Okay. So I have agreement. So this time H is the midpoint of CE, and this is parallel to CF. So this is the mid segment, and the G is the midpoint. Okay. So we buy this since HG parallel CF. H is the midpoint. That HG is the mid segment. In particular, G is the midpoint of EF. So we started with a trapezoid, but our proof rely on triangles. We connected this point, we get two triangles. We use the midpoint for our triangles. Okay, so Kira picked this point C. After class, you can check. You can pick point A. You can pick point B. You can pick point D. They all works. Think about it. How to make the proof work if we pick A. If you pick B, if you pick D. Should be similar. Okay, that's a hint. Okay, for you to think about.
Well, if you pick A, then you have to put C and F on the AC line, I think.
If I pick A, what should we do first, Aaron?
Move that black line from point C to A, and then point E to CD, I think, somewhere.
Okay, somewhere, yes. So, okay, you will try and think about, you see if your argument works. Okay, next one. Okay, the intercept theorem. Okay, first, what is this theorem about? Isabella, the intercept theorem, what does it say?
I'm not really sure.
Okay, so the intercept theorem for any triangle. we draw, okay, maybe this is good intercept. Let's draw it here. A, B, C, E, F. Okay, so EF parallel to BC. This implies, Eric, do you remember this? What can we see from here?
Oh,
E equals to 1, a fraction of AB, and F equals to the same fraction of AC.
Okay, okay, Aaron, what about you?
hold on. I wasn't ready yet.
Okay, okay, okay. So if this line is parallel to BC, then the corresponding side have the same.
Wait, isn't it D, not F?
Well, you could use D, but I use F, so F also
Oh,
works.
okay.
So AE over AB is AF. Okay, my A is not good. Let me rewrite this AF over AC. It turns out to EF over BC. And the intercept theorem, this is equivalent. You can go both ways. If we have the parallel side, we have the equal ratio. If we have the equal ratio, it must be parallel to BC. Okay, when we apply this, AD make it a little bit not regular. A, B, C, parallel to BC with D on AB, AD, D. Actually, a different color make it more transparent.
Excuse me? Something doesn't look right here. You said E on AC on the previous one and D on AB, so
On the previous one, now it's different.
triangle. Are you doing, I mean, like,
Now okay. Now
bugs me
this is a
out.
different triangle.
Okay,
For
good.
this one, D on AB, E on AC for this one.
Yep.
Okay, this will be D, E. What we know, AD is 3, BD is 6, AE is 4. What's EC?
Five.
Why?
Wait, hold on, wait.
Okay, maybe enter your answer in the chat if you find the number. I will check.
Wait, no, it's 8.
And think about it, what it should be. Okay, why is 8? Okay, Eric.
If you simplify it, then 3 over 6 equals to 1/2. So that means right now 4 equals to that 1. So we have to do 2 times 4 equals 8.
Okay, so we have the equal ratio. AD over BD is the same as AE over EC. So AD is 3, 6, 4. This must be 8. Okay. What is this? Okay, SEC. Next one, line ADE parallel to BC. No, different color. A, B, C. D and E. Okay, so this time it's not about the, okay, you got the chatting, let me disable this. Okay, the condition. A line parallel to BC. It creates segment that is the trapezoid BCED has area 3 times of the area of ADE. We want to find the ratio AD over DB. So I will use red for area 3, 1. What is this ratio?
What's the formula for finding area of trapezoids again?
Okay, there are different formulas. One of them is you add this, multiply by the height, then divide by 2.
Wait, what was it again?
Okay, and let me. I can give you the formula, but it's not very helpful in this situation. We could have the formula. You have A here, B here. And H to the area. I'm not sure how helpful this is to this problem, but it's useful. It's useful knowledge. Okay. Amy, thoughts? How do we use this information? 3 times the area of the triangle.
I mean,
Okay.
I'm not sure.
Okay, let me ask you, what's the ratio of this area with the big triangle?
1 to 4.
Okay, Aaron jumped in, so what we know is the area ADE. Area ABC is 1, 3. Okay, is this helpful? How do we find the ratio AD and AB? Okay, Eric.
So AD over AB equals AE over AC, which is equal to DE over BC.
Uh-huh.
So, wait. That doesn't really help.
Okay. So we know these two triangles are similar. So the ratio of the area is the square of the ratio of the sides. And why is that? Maybe one more step, it will be the square. The reason for this, let's recall the formulas for the area. There will be 1/2 of the
Wait, I think I
product.
got it.
Okay,
I think the
area.
ratio, I'm not quite sure of the answer, but I think it's 1-to-1.
Okay. So then AD over BD will be 1-to-1.
Aha.
Okay. So the ratio of the size of two triangles is the square root of the ratio of the areas. Okay. Because the area will be AD AE sine angle A. AB AC sine angle the same angle here. So the ratio of the area will be the square of the ratio of the side. Okay, number 3. Bisector mid side the line. Okay, a little bit evolved. Let's try to draw a triangle. A, B, C. The bisector of angle A. Bisector of angle A. Oops. Move. Okay. Meet at the point D. Okay, the first step, we draw the angle bisector. Next step, we draw the from D parallel to CA. Draw a parallel line. Okay, so about right. So at the point E. Okay, now we want to check triangle ADE is isosceles. Let's mark. Why is it isosceles?
So do we have to prove that E is the midpoint of AB?
Okay, let me move this slightly. Okay, E is the midpoint of AB, and why is that? Is D the midpoint of BC?
D the midpoint?
Is it?
No.
No. So AD is the angle bisector. That is the condition.
If we flip it over and look for the intercept form, that means BE over BA equals BD over BC.
Mm-hmm.
So that also means DE, it's also equal to DE over AC.
Mm-hmm.
So triangle BED and triangle ABC are similar.
Okay, they're all correct. How does it help? How could it be helpful to our conclusion? Why is this? Let me maybe emphasize this.
Wait, I just want to
Yes.
clarify. Isosceles is when two angles are similar, but the third one's like not.
Okay, that's too wide.
Ah, yeah.
Oh, this is for the intercept form either way.
Jessica, Amy, and any of you, Kira and Isabella. Where should we?
How do we use the angle bisector?
That's a very good point. We will need this. How? We will need it.
Is it because AD is part of ADE? Is that why?
Aaron, what's that?
Let me think. Angle A,
Uh-huh.
I think. And you said, and I think we might need it because AD is part of ADE. I mean, the triangle.
So the condition, I'm going to label this angle 1. Oh, it's not this color. Angle 1, angle 2. We know angle 1 equals angle 2. It's the bisector.
Uh-huh.
Okay. Why this triangle isosceles? We're getting very close. There's one tiny step. Something we used today will be the first half of the lecture. Okay, we used this information is the bisector. What the second? We haven't used this yet. The line is parallel to AC.
Wait,
Uh-huh.
wait. Opposite interior angles?
Okay, so that's getting
Wait,
close. What's it called?
um,
If I will go to the first page. Some angles we introduced. Correspondence angle, alternate interior angle.
alternate interior angles.
Okay, so that's where we are heading.
So
Okay.
since angle 1 equals angle 2, that
Uh-huh.
means angle 2 is also and also angle 2 equals angle ADE. That means
Okay,
angle
I'm going to
1
call this
equals to
angle
angle
3. Okay, angle 2 is angle 3. Why, Eric?
because if you turn your head, you can see that since AC is parallel to ED with
Uh-huh.
AD transversal, that means
Uh-huh.
you see that angle 2 and angle 3 are alternate interior angles.
Okay.
Since angle 1 equals angle 2, then angle 1 equals angle 3, which is using algebra. That means angle 1 equals angle 3. And since in isosceles, two of the angles are equal, that means this is an isosceles.
Okay, so two assumptions. One, angle bisector. Two, parallel lines. Therefore, first one tells us these two angles same. Second one tells us these two angles the same. Then with angle 1 is angle 3. So the triangle is isosceles. Okay. The next one, I'm going to do the same thing and you draw a triangle. A, B, C. I will start with the bisector.
This is just like the last question, but there's one more parallel line.
Okay, that's right. I'm trying to recreate the parallel line.
Why don't you just copy the picture from 3 and then move it down here?
Well, I could, but it takes some steps, so I would rather redraw this.
Oh,
That also works.
yeah.
So next step,
Is
from E parallel to BC,
To AC.
to AC.
BC.
I think it's a F, I think.
Okay, parallel to BC, meet A at F. Parallel to this, we intersect this.
Mm-hmm.
I will use a different color.
F.
Okay.
EA equals FC. Hmm.
All right. EAFC. Let's
Option.
mark it down.
Okay.
Oops. Yes. EAFC.
We could just
So
focus on the
we
trapeze.
know E is the midpoint of AB, right?
No, I have why? I have no idea.
We didn't say that. I don't think we said that.
Wait, no.
I
Oh.
think it only said bisector meets BC. It didn't say
Right.
midpoint.
So this is the angle bisector, not the median. If it's a median, D is the
Yeah.
midpoint, E is the midpoint, but now it's not.
I think we're not looking at the
EA
median section.
equals to FC.
Actually, no. All right, bro, stop copying me.
Okay.
Well, that does encompass a trapezoid, EDAC, I think.
Oh,
There's also a rhombus.
intercept theorem?
Like, if you turn it around, like, it'll basically become like
A
looks like
quadrilateral triangle.
Okay, two of you.
There's
Kira, what's that?
also another trapezoid. There's two trapezoids and a rhombus.
That's true.
Well, yes. I don't think we're focusing on the rhombus though.
Okay, we have a lot of informations, but our target is this two. Jessica, think about it.
Oh wait a second.
We can
Wait a moment.
Eric, stop. Amy, say something.
so if we say that DEA is an isosceles, then we can prove that EA equals DE, which equals FC, right?
All right.
Well, we can
Okay.
say that D is parallel to FC. I think.
Okay, so the main steps, I will ask you why. So AE equals DE. DE equals CF. So this is Amy's argument. AE equals CF. Okay, Kira. Why these two segments the same?
It's an isosceles triangle, so two of the sides are the same.
Okay, it's from the previous step.
Well, angle A equals angle D, I think.
Well, okay, we have so many angles. This it's better to see angle 1, angle 3.
Well, yeah. Angle 1
Okay.
is equal to angle 3.
Okay, so this is from the previous step. It's isosceles. Okay, Jessica, why are these two sides the same?
Because of the they're parallel and
Okay.
like it's in rhombus.
There's no rhombus here.
Oh, never mind. Well, they're parallel and
Okay, Eric.
ED and FC are both parallel, and also EF and DC are parallel, which means CDEF is a parallelogram, which means EF equals DC and ED and equals FC,
Okay.
which means FC equals ED, yeah.
D, C, D, E, F. Okay, because from our construction, DE is parallel to this. The second construction is parallel to BC. So we get a parallelogram. The two sides of the parallelogram, they have the same length. Now AD and CF, they are the same. So we build up on the previous one. Okay, so we will stop here today. Next
Wait, what
time.
about sections 5 and 6?
Yes, maybe next time.
Okay.
Okay, so you can check the questions, try to finish them as many as you can.
Okay.
Okay, see you next time.
Bye.
Thank you. Bye.
Okay.
Can you stay here for a little bit? 'Cause I
Yeah,
don't-
sure.